All right, welcome back. We have some sample, and we know it's somewhere on our normal distribution. Maybe it's close to the mean, maybe it's close to that peak on our distribution, maybe it's not. We have no real way of knowing exactly where it would be, our sample. But we do know that this is a normal distribution, which means, like all normal distributions, 68% of all samples, maybe ours is in there, maybe it's not, are within one standard deviation. 95% of all samples, maybe ours is in there, maybe it's not, are within two standard deviations. And 99.7% of all samples are within three standard deviations of that population parameter, proportion in this case. So our sample, I can't say with 100% certainty that it's specifically anywhere around the parameter, but I can say with a level of confidence that, yes, for our proportion, 55% there, that's our best point estimate. It's not likely that the population parameter is exactly 55%, but I can say with, say, 68% confidence that the actual proportion, whatever it is very close to P. This being P hat. I can say with, say, 95% confidence that the parameter is somewhat close to P hat, which is 55% for us. And I can say with 99.7% confidence that the parameter, whatever it is exactly, is at least a little bit close to our sample. So whenever we talk about speaking with confidence, it's always a level of confidence. And so what we're going to do in this video series is come up with a level of confidence that's appropriate for our situation. So we're going to decide that. And this is something I want you to keep in mind through this whole section when you're watching these videos, when you're working the problems. First, you decide what confidence level is appropriate for your situation. And we'll talk about that first. After you've got that decided, after you've decided on what confidence level you want to shoot for, we will use some technology or z-tables to find what's called a critical value. So you'll look that up. Once you've got that looked up, you will use it to calculate the margin of error, and that will produce your overall interval. That's going to be the process start to finish when we're trying to discuss how to find population parameters, or at least estimate them based on a sample. So first things first, how confident do you want to be? And that's something you always have to decide on before you do anything in this section. Now, most of the problems you're going to be assigned, they'll just straight up tell you choose a 90% confidence level or a 95% confidence level. And if you don't know what you want to shoot for, just take 95%. That's the industry standard. If you don't know any better, you don't have a specific preference one way or the other, 95% is a good confidence level to shoot for. If you're going less than that, you totally can, and that will be good for giving a quick estimate where you're okay with being wrong. Uh, that's totally fine. You can go under 95%. Whenever you want to go above 95% into the 99% confidence level or even higher, that's where you're really, really wanting to make sure you're never, ever wrong. So a 99% confidence level might be where there's a risk of losing money if you're wrong. That might be a problem. The other two I've added from my engineering experience. A 99.9% confidence interval might be useful if you are making a product and you want to avoid any risk of injuring people. And a 99 point, you can go on forever, right? You can have like 99.999% confidence interval. And that is where you are really afraid of failure because failure might get someone killed. And that's something you really want to avoid. And so that's when you might have these really high confidence levels. But really, for just statistics, just crunching numbers, shooting from the hip, 90%. If you can't decide otherwise, 95%. And that's going to be it for choosing your confidence level. In the next video, we will look up using technology to find what's called the critical value, and then we'll go from there. So I will see you in the next video.